Okay, notes for 6.3. What we're going to do is learn to divide polynomials using long division. And then we're going to use a shortcut which is called synthetic division. And what this is doing for us is, well, first of all, we could just divide a polynomial by a monomial. If we do it this way, then really what we're doing when we have plus or minus in these things, what we want to do is think about each term. Now I can only do this if this is an entire group, and then I can split these up by dividing each term here, each term being split by a plus or minus, each term being divided by the whole denominator. Okay, and I'm allowed to split that up. I'm only allowed to split up pluses or minuses in the top of this thing. I cannot, if I had plus or minus in the bottom, we could not split that up. So then we just go through for each of these and cancel out what we need to, so we get x squared there. The y's cancel, leaving me with a y on top, so there's nothing left on the bottom. For the next one, the 4 and the 8 gives me a 2. The x's cancel out. Y and y squared leaves me with a y. And minus, and 4 and 12 gives me 3. X squared over x is leaving me with an x on top. Y cubed over y leaves me with a y squared. Okay, so that shouldn't be too hard. Now, where this gets difficult is, well, actually, before we do that, remember what a negative exponent does for us. We would just rewrite this but we would divide it by this as negative exponent, means it goes in the denominator. Same thing in this one, except it would be 3xy squared, and so you'd want to go ahead and square that before you start dividing this one. Okay, now some of the things we're not going to be able to do that way because we're going to get things in them that have a plus or minus in the denominator. And so we're going to use a different method of doing this using long division. Now just a review of long division, usually what we would look at here, we would see, well, can 52 go into 3? No. Can it go into 35? No. And then we would look maybe at the 350. We consider the 52. It's almost 50, so I might say, well, maybe about 7 times, but not quite, so I'd use a 6 there. And then we could subtract and get 38. Then we would bring down the 4 and kind of go through that process again. 52 into 38, probably about 7 times, because 50 would be 35. Check it, you get 14, 36, and then we're left over with a little bit. Now there's a few different things that we could have done with this leftover part. We could just say, like the first way you probably learned this was just to write remainder 20. Then you might have learned, well, we could just keep adding zeros and make it a decimal, but we don't really want to do that on this one. The other method of doing this was remembering that this is what we're dividing by. So we could change this so that we have whatever our remainder is divided by whatever our divisor is. So this would be 67 and 20 over 52, or reducing that some more, that would give us 5 over 13. Or you could think of that as 67 plus 5/13. And so just remember what you want to do with this remainder here is go ahead and write it as a fraction over whatever this divisor is. And we do that because we can rewrite this one as a long division problem. We can't do it the first method, the way we did on that first page, because we don't have, this is a minus in here, and so we have to keep that all together as a group, and so dividing each one of those by that is not going to help us. Our method for this then is, for the most part of this one, we only look at the first term of the divisor. Now, and we want to see how many times it goes into each of these things. Now we're always going to start over to the left of this, kind of like what we did in this one when we started dividing into this. The 5 went into 35, but we're looking at the whole group, and so we started over here. And so this one, again, we're going to start with that second term. Now one thing you want to make sure you're doing is this, notice is z squared, then we have z, and we have 24. For the most part we want it to be counting down like that. We need it to have that in that order. Okay, so I checked the z, and I just want to look at this, the z and this z squared, and I would multiply that by z, because z times z gives me z squared. But I would also want to multiply the z times minus 4, which would give me minus 4z. Now our next step in this one was we subtracted here, and that's going to be our next step here. But be very careful here. Remember that we're subtracting the whole thing here. So this is, well, this one gives you 0 here, and that's why we chose the z, is so this would subtract out and give us 0. On this one, though, we have to see what it's going to do. 2 minus a negative 4, which gives us a positive 6z. Our next step then, just like before, we bring down whatever's left so that we can move on to the next step. We consider this over here and see what happens next. Okay, so z into 6z, we would multiply that by a positive 6. So 6 times z gives me 6z. I would also multiply times the 4, negative 24. And then again, we subtract the whole thing. 6 minus 6 is going to give us 0, and negative 24 minus the negative 24 is also going to give us a 0. And so we're left with no remainder, and our answer to this would be that when we divide this, we get z plus 6. Now we could check that. Remember we had z minus 4. The opposite of division is multiplication, so I could check my answer of z plus 6 by multiplying these together. That would give me z squared plus 6z minus 4z minus 24. This would give you a 2z. So notice that we could have really done this just by factoring this and checking what we would get if one of these is the denominator. Now that's only going to work if it's factorable. If we get a remainder here, we couldn't factor it. So we just took an easy problem to see how to do the process. But this is usually more useful if we're going to get a remainder, if we can't divide it, if it's not easy to see it by factoring it. Okay, now the next thing they do is they show us a shortcut. Oh, let's look at what to do with the remainder here. So if we have a remainder, okay, we're going to go through the same step. Notice what they did here. They had 5 minus t, but they wanted t to be first, so they rewrite it as negative t. They look at the t squared there, and they see that t squared goes in negative t times. So negative t times negative t is going to give us a positive t squared. They would also multiply that 8, well, I'm sorry, the t times 5, basically we don't have this yet, sorry. Then they would multiply that, which gives them a negative 5t. They subtract that whole row, which would give you here a 0, but then the positive minus the negative gives you a positive 8 there. They bring down the 9 and check, looking at this, just again looking at the first thing here, we only look at the negative t and whatever's first here. So we would multiply by negative 8 to get a positive 8 for the, they brought down the 9, they multiply that now, and so they get the positive 8 here. 8 times 5 is negative 40. They subtract the rows, and then that leaves them with a positive 31 left over. So this is a remainder here. And we could just write it as remainder, whatever, but that's not really going to give us a good answer. So what we're going to do with our remainder is we're going to write out, okay, what we had up here, and then we add the remainder as a fraction over our denominator. So I was dividing here by this, or they actually use this one, and I just write the remainder on top of that. So that's basically how we do long division. Now, what's next is called synthetic